Hi everybody, we are still working on dividing fractions. Today we added one more twist, and that would be with sometimes, instead of just fractions, you can see that some of these problems that we're working with now have mixed numbers. So instead of coming up with a whole new set of rules, we can continue working with the same patterns that work with dividing fractions because all of our mixed numbers can be rewritten in fraction form. So let's go ahead and just take that first problem, the 3 and 1/10. And if I want to work with 3 and 1/10, I can decompose that problem. I know that 3 whole is the same as 1 plus 1 plus 1, right? So I know that I can take 3 whole and I can rewrite it differently. With fractions, though, I'm dealing with tenths. So I can decompose or rewrite 1 whole as 10 tenths. And I have 3 sets of that. So 10 tenths plus 10 tenths plus 10 tenths, there's my 3 whole. Plus I have the 1 extra tenth there as well. So I have a total now of 31 tenths. So there's why it works. The shortcut then, once you know that, is if you have 3 full sets of 10, 3 sets of 10 is 30, plus I have this 1 extra, there's my 31 tenths. So there's a shortcut, but here's what it looks like. I know that 3 full is the same as 10 tenths, 10 tenths, 10 tenths. There's 30 tenths, which is 30 divided by 10. There's your 3 plus your 1/10. So now that I have that set, I can go ahead and I can follow my same division rules. So 2/5 divided by 31 tenths. I can do two different ways. I can find common denominators, and in this case, I can take my 2/5 and I can rename 2/5 as 4 tenths, and I can say, oh, 4 tenths divided by 31 tenths. And since I have that common denominator, I can go ahead and I can just divide my numerators. 4 divided by 31 is 4 over 31. 4 over 31 would be my final answer. Or I can use my multiplicative inverse and the pattern that we had been working on before, and that's rewriting our division statement as a multiplication statement. So I can say 2/5 and multiply by the inverse or multiply by the reciprocal, and the opposite of 31 over 10 would be 10 over 31. And then I can work that out, multiply that out right now. Well, you can see I'm going to get a much larger number. So we've been working in class and talking about ways to look to see if you can simplify before you multiply. And as long as you're simplifying a numerator with a denominator, it doesn't matter if it's in a different fraction, because I can rewrite this as 2 times 10 in my numerator and 5 times 31 in my denominator. When I look at it that way, I can see that my 5 and 10 can both be divided by 5. So 5 divided by 5 is 1, 10 divided by 5 is 2. So now when I multiply that out, my numerators are 2 times 2, which is 4, and 1 times 31, which is 31. And my answer is 4 over 31. And what I should have done at the beginning is just kind of taken a look at my original problem just to make sure that my answer makes sense. I have a small 2/5, and if I'm dividing that up into 3 and 1/10, I know that I'm going to get smaller pieces, that my answer is going to be smaller than 1. And if I look at 4 over 31, that's a very small part of a fraction, so my answer actually makes sense. I hope this helps in your practice. Make a difference today.